Good evening, everyone. My name is Sam Nasser, and this is the October meeting of the Cleveland C# VB.NET User Group. The meeting occurs every month, typically every fourth Thursday. However, today is a little bit of an off night to accommodate a scheduling change. The meetings are free of charge and open to the public, and we discuss any and all topics related to .NET. You can find meeting information for future meetings as well as past meetings over on meetup.com. And the link is posted there at the bottom of the slide. I'd like to give a big thank you to our sponsors. Although we haven't met in person for a while due to COVID, we'd like to thank Tech Systems for always supporting the group and providing the meeting space. We'd like to thank Inito for providing the pizza and drinks, and PostSharp for providing the prizes that we used to have in person, and also NIS Technologies for providing the hosting services. Some general information. The only applicable bullet point here is that participation is encouraged. Also, during the time when you're not asking questions or participating, I kindly ask you to mute your microphones. But whenever questions arise or comments, feel free to jump in. Tonight's presenter is Sumit Sengupta, and he is the Cloud Solution Architect for Microsoft. And he's going to be discussing multi-model databases in Azure SQL. And so with that, I will turn it over to Sumit, and I will make him presenter. All right, take it away, Sumit.
All right, can you hear me?
I can.
All right, thank you. Well, good evening, everyone. I guess everyone is local, so good evening is the right way to say it. My name is Sumit Sengupta. I'm a CSA Cloud Solution Architect with Microsoft. I work with a lot of partners across the country, and I primarily work on Azure Data Platform. Well, Azure is my only focus, of course, being in cloud. Mostly on database platforms, which means SQL, also Cosmos DB, Postgres, MySQL, etc. So tonight, is that a question? Yeah, do you mind? I can't see Sumit's screen though, of course. Yeah, I'm not sharing, Sabrina. I haven't started sharing. Good point. And also, just to know, I mean, this is such a small group, right? So please open up, sure, you're welcome. Have any questions you have, you can ask me, you can stump me, you're more than welcome to do that. I don't have a whole lot of slides. I actually have quite a few slides, but I have a lot of demo to share, actually quite a few samples that I'm going to share with you, so you can run these. Okay, so with that, let me start with the deck. Slideshow. Okay. Let me know if you see it. How do I minimize it? Oh.
Yep, you're good.
All right. Just want to go to another window. Okay. So today, what I thought I would talk about is, oh, didn't move forward. That is odd. It's supposed to. What happened? Didn't work here. Okay, there you go. Okay. So what we mean by multi-model support and what different models we can support in Azure SQL Database. And when I say Azure SQL, I mean generally I mean the PaaS platform, but there are subtle variances between the PaaS platforms themselves. So for example, Azure SQL DB versus SQL Managed Instance. There are other versions of Azure SQL, like SQL, for example, running on Edge. You can literally run SQL on a Raspberry Pi devices. Also, you can have, well, I'm not going to analytics and Synapse right now. Also, of course, you can have your own VM and run that in Azure VM, and has what we call a resource provider. So within Azure, if you spin up a VM and you install SQL on it, it's obviously you're in charge of this machine, you're by yourself, but you can register that machine as what we call a resource provider. If you do, then Azure sees it not just as a machine with anything got installed in it, but as a SQL Server VM. So Azure will automatically do things like backup, patch up, upgrade, etc. So anyway, all of that have different flavors. In general, these things, what we're going to discuss, works across all of them, but there's some slight variations on that. So what do we mean by multi-model? We're talking about support of JSON, support of geospatial data, support of XML, etc. So the thing is that we have all these NoSQL databases. Oh, by the way, my background a little bit. I'm with Microsoft for about 4 years. Before that, I have worked in various places, many years with HP, few years with Intel, few years with Ford, and 1 year with MongoDB. So I worked on different database platforms, including a lot of the NoSQL databases platforms. And one of the reasons that NoSQL databases are so popular because they offer features like quote unquote JSON, native JSON support, right? So today, what we're going to show is that you can do a lot of those stuff in SQL itself. Again, if you have any question, and I'm not watching the chat window, Sam, if you don't mind, if you have a question, if someone doesn't want to speak, just read out the question or comment for that matter.
Sure, we'll let you know.
Thank you. So Relational Engine is the backbone of everything. Well, it's kind of going off topic, but even today, I would say about 80% of the database platforms is still relational, like more relational than non-relational, right? So even though we have things like MongoDB and you have Cassandra, you have HBase, all this non-relational databases, relational databases is still like a bulk of the data stores is relational. And most of the new applications development, in fact, is still using relational databases. Obviously, there's benefit of relational databases, transactional support, write, optimize, backup, recovery, yada, 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 etc. So when we can combine the benefit of the relational engine with the multi-model support, and again, when I mean by multi-model is supports like JSON, geographical data, XML, etc. We'll talk about. It gives you kind of the benefit of the both worlds. You don't have to change the database platform. Now, for complete clarity, a lot of those things will be supported in platform like our Azure Cosmos DB as well. In fact, Cosmos DB natively supports JSON. And quite frankly, there's a lot of times people ask us questions like when to use which one platform, and that's often how do I say this? There's no straight answer to this, right? So certain services have certain benefits. It suits better in certain use cases, and I'm more than happy to answer those questions if you have any. Okay, so JSON support. So what you're seeing here is that Azure SQL, it fully supports storing, manipulating, and creation of JSON documents, right? And this is important because you don't have to use a MongoDB. You don't have to, remember, you still have a choice, right? Or Cosmos DB or anything like that to store JSON. So in this example, what you're seeing in this picture here, you have two documents. So the first one within the curly number, like number, date, account number, price, quantity, etc. And the second one is another one of those. So you can think of it like a two row. So what we're seeing here is essentially you can take the whole JSON and flatten it out as two rows and put it in a relational table. So what SQL stores inside of those tables is SQL sees it just as a regular table. In fact, regular table with n varchar columns. But you can represent it as a JSON. So there are built-in functions, and we're going to use some of those functions. I'm going to show you in a demo. So you can do back and forth transformations, reads and writes, etc. Let me pull up. Actually, this is the next slide, maybe. So there are some samples, and you are more than welcome to take this, clone it, use it, test it, any of this stuff. So the first one, I'm going to run some of the queries from the first one, and the first one itself has quite a bit of other stuff besides JSON. And these three ones are pretty neat, like a very simple way to interact with SQL using Python REST API or .NET or Node REST API. And finally, this is a full stack application example. This is just a to-do website. So you just pull up a website and you say, this is my task to do. I enter something, just one-liner, edit it, delete it, etc. So with that, I'm going to jump to demo. Before I jump to the demo, I think I should show you the data set that we're going to look at. So this is my data set, and it's very simple. I like it because it's so simple that I can understand it. So it's got 2 rows, as you can see. Well, actually, is it 2? Yeah, I think 2. So one document ends here from line number 2 all the way up in line number 29. We're talking about one person. His name is John Smith, age, address, phone numbers, and children, if he has children or not, spouse now. So this person seems like not married, doesn't have a child, has 3 different phone numbers, has an address, like a regular street address type. So the thing important is this is all a JSON. Well, primarily this is how a basic JSON looks like. So you've got key value,
Sumit,
key
if I
value.
may interrupt you.
Yeah.
There's a request to make the text bigger on the screen.
Oh, okay. So continuing on. So basically what we're saying is that a JSON document is, that's all it can have. It can have a nested field, like so within a field of, multiple key value pairs, and then even array of fields, phone numbers, yada, 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 etc. And this is one person, and then we have another person, Maggie Doe, she's 32, whatever. She does have children, 2 of them. And this is all 2 people. So we're going to insert these 2 into SQL tables, and we'll see different manipulations using JSON. Okay, so let's look into that. I think I have to switch my monitor. Oh, let me just make sure. This one, yeah, okay. So this goes here. Switch my monitor, stop sharing screen. Sharing screen. And then this would be, oh, this is so odd. It numbers it like different way that I'm used to in Teams. Let's make it sure you can see it. Okay, what do you see? Do you see Azure Data Studio?
Yes.
Okay, cool. Thank you. Finally, the glitches of remote working. Okay, so let's lower this down. So this is Azure Data Studio. By the way, if you're not using it, you should by all means. For one reason, it's very extensible. This is one tool that will connect to, for example, SQL as well as Postgres databases, if you would like. We don't have a MySQL extension yet. Okay, so what we're doing here is as you can see, we can drop in 3 different tables, and we're creating these tables. So let's run this, and we have a table, user phones, user addresses, and users. So the users table, so we're going to take those 2 JSON data that we saw, 2 people, and we're going to put it into these tables. And as you can see, the table themselves are nothing abnormal in the sense they're just regular tables. So create table users with these fields. And in this user table, what we did is put two people's name, John Smith and Maggie Joe. Then we create a table called DBA user addresses. We put their address in this. So ID, user ID, street address, state, postal, etc. And then we have a separate table for phones. So user ID and what type of phone it is, office or mobile or home, etc. Right? And then finally, this is the regular table, and we have created what we called a JSON table. So this is a JSON table. We call it dbusers.json. And what we're doing is we have a single ID field. So ID is just a 1, 2 natural number. And the JSON data is an nvarchar of everything that we have put in there. And in that, what we do is we put, if you notice, the whole array. So starting with John Smith's information, comma, Maggie Doe's information. Sorry, John Smith's information goes as 1 row with ID 1. Maggie Doe's information goes with another row with row 2. So that's how we're just inserting this dump data, and now we're just doing a select star from all those 4 tables. So of course, the first 3 tables are regular tables, and the 4th one is the JSON table. So again, first table is for users, second one is for address, third one is for phone number, and the 4th one is JSON data. So if I pull this up, you will see that basically we have the third one probably existed already, but we have 2 rows with the person's name, age, address, etc., etc. Okay. Now we're going to do some JSON query. So this is where the kind of the beauty and the power of JSON comes in that we're able to manipulate it. So the first example here is, let's run it one at a time. And by the way, Sam, let me know if it's too long, if we cut it short, if I'm too slow or whatever, too fast, that's fine too. So JSON variable, so what we're doing is we're putting it at JSON variable is JSON data from DB user. So basically just selecting that column from the DB users JSON table for the first row, right? And so if I run it, by the way, this is the another advantage if you're not using this Azure Data Studio is you can actually run it like a notebook style. So you can put your comments, stuff like that. So the next example, this is just we're putting the name, right? So nothing else. If you notice what we did is that we said JSON value is a function and took the first name. So and the whole thing, I'm just parsing. If I can show my Visual Studio again. From the whole data set, I'm just parsing this field, first name John, and that's all I want to display. So basically, as if I'm displaying just one column from a regular table, right? So then this next example, what we're showing is extracting non-scalar values from JSON. So here again, we are deploying the variable. And what we're doing is we're saying that get the JSON data, and what we're querying JSON star $.address. So what the $.address tells is it actually takes me and just gives you the address information. So here again, if you remember, if I will put my Visual Studio data again. Oops, come on. I cannot do this. I cannot move my mouse. So when we say address, this is the address. So this part of the document. So inside the document, we have a sub-document, and that's the sub-document is what we're interested in. And it pulls us the sub-document for John Smith. Next example is we're using a different function. So the only thing we are doing different is we're using kind of a different function of SQL, right? So we're using a different function here, an OpenJSON. So with OpenJSON, it's possible to operate on JSON in more powerful and flexible ways. This is where you can do like joins. For example, this cross-apply operator can be thought of as a for each operator. So you can actually, together with this OpenJSON function, it allows you to like easily operate on all JSON stored in a table column just using a declarative approach. And as you can see in this example, what we are going to do is we're going to actually so we're taking one horizontal document and we're kind of spitting it out as different rows on a table. So what we're saying is select j.id as document ID, t.star from DB users JSON, that's our JSON table. Cross apply is a self join with the same data. j.json as t, where ID equals 2. So just to make life simple, we're actually pulling it for only one user. And we get the information for Maggie Doe. Again, the idea is that we took the whole document, right, and parsed it within the different fields and put the different fields as a different row, and it appears as if it's coming from a single relational table. So with a different structure, of course. This is very powerful. And again, you don't need to take notes or any of that stuff because you're going to get a copy of this deck as well as the GitHub samples. Oops, I can go down. Okay.
There's a question in the chat, Sumit.
Yeah.
When
When
you
you insert
insert
data
data
JSON
as
in DB, does it create a default index using ID similar to MongoDB? Ah, Sabrina, very good question. Honestly, I don't know, and I don't think it does. But to your point, yes, in MongoDB, if you create a data, well, actually, you know what? Why don't we see it? We got the database as created, and we're doing it in multi-model. So there is my multi-model and tables, and DB uses JSON. Come on. No, I guess that is an index, unique index. So yeah, it does create a unique index, it seems like. Continuing on, if Maggie had two children, if you remember, so we want to get those two children's information. So get c.value from this table. And again, using OpenJSON, using cross apply, we can just pull out just those two children information. In this over here, we put out all the information. Over here, we're just restricting it to just the array inside of the document. So instead of getting key value pairs, it's possible to apply to JSON and get a regular table as a result. Here, the column names are what you specify, and we get a regular table in result. So the idea is that we're selecting j.iz document ID, t.star, J is the JSON table, cross apply with we're taking here we're taking a subsection of the same table. We're taking first name, last name, age, etc. When we do a cross apply and we pull this information out, we basically get the first name, last name, age, and state. Again, it appears like it's coming from a single table. And just to make it simple, actually we haven't run it, so let's run it. We get this information about first name, last name, age, and state. So that's end of this one. No, we do have one more. Okay. If JSON has nested objects, like in this case we do, like we have an address, it's possible to use OpenJSON multiple times. In this following example, what we are doing is we're passing the phone numbers as a passed as a JSON to a nested OpenJSON that operates on it. And this time the outer apply is used instead of cross apply, as it will return rows even for those JSON documents where phone numbers element is missing. So we don't have a phone. If you only want to get rows if phone numbers element exists, then what you can replace outer with inner. So obviously instead of outer, inner join, and run this query, and the result shows like this. We do get Mark Brown's information back, even though he does not have any phone number. So the idea is that you can do OpenJSON on one and feed that into another OpenJSON. So you can really nest that like that. All right, so that's example one. The second example I was going to show is actually how we can modify the JSONs. Okay, so there are functions called JSON underscore modify. It's possible to manipulate JSON to add, remove, update elements, individual elements. So you got the whole structure. You can update any individual element like that. So over here, what we're doing is John Smith children. This is our JSON. Remember, we're not selecting any from any table, we're just getting the document as a JSON. And then what we're doing is we're updating you. So basically changing his name, making him alive, adding his preferred color, saying that he has a children or child one, etc. Okay, so oops, okay, I need to connect. I will be this database and it will be multi-model. So all we're showing here is that with different names, I'm showing the capabilities. So when I change name from John to Dave, it becomes Dave Smith, right? When I insert a scalar value, I can insert a scalar value like he's alive, it's true. I can insert an array, so I can say preferred colors is 2 colors. I can append to the array, so he didn't have any child, now he has a child. I can replace an array with a scalar variable. This is neat. So here, if you notice very carefully in line number 4, we have an array, supposedly children, 1, 2, 3, 4. We kind of replaced it with a scalar key value pair, right? We can add an object, like we can add a phone number, which itself is a document, nested object. And of course, you can remove an object. All of these functions is using some manipulations of JSON underscore modify. So in a way, we're doing multiple um, multiple complex updates, right? In a relational world, you will consider it that way. Okay, changes can be done right in place without the need to load JSON into a variable. So in this example, what we're saying is that we don't need to load the JSON into a variable if we would like to change it. So add a simple user where Joe Black is a new user being added. We're updating the last name, so modifying the name from black to green. We're adding a phone number, so JSON data modifying the phone number, etc. And we'll view the result where ID equals 42, his ID is 42. Okay, so let's do it. So here, we were able to modify it without loading the data in it. So essentially what we did is updating the name and added the phone number and view the results. Okay, this will clean up his record, and for the sake of the demo, actually we'll do it. Next up is we're going to do this one. And this looks good. Yeah, okay. If you want to create one document per row instead of having big JSON document everything, you can use JSON query. So there is a different function we're going to use. Oops, sorry, just not the start of it. There's a powerful thing called for JSON. So what we're doing here is selecting a bunch of fields from the fields, inner joining from a different table, right? And we're doing for JSON auto. So what you notice is that in this query, we're actually not selecting from the DBO users underscore JSON. We're actually selecting from the regular tables. If you remember, the first tables we created were actually the regular tables. If I go back here, the first tables we created were like this. Oops. Like regular tables. So over in 3, what we're doing is taking data from this regular table and representing this as if they came from a JSON and they look like JSON. So all we're doing is with for JSON auto, and auto is smart in that it actually can represent the data and it can show it as a JSON field. So here it looks like that long Visual Studio 1 document. Just for simplicity, we're picking one person. So this is Maggie. Now, for JSON Auto, what it does is it formats this automatically as a JSON document. You can do a little bit more tricky things with JSON underscore query. And by the way, there is, of course, gazillions of documentation around that, but I'm just now showing you a demo. So over here, what you're doing is that, oops, this is also JSON Auto. Where's my JSON query? Oh yeah, here's the JSON query. So with the JSON query, I have formatted it with a specific way that how do I want to do this? And if I do this, then the result looks a little different. So here's the results with JSON query versus here's the results without JSON query. The difference is over here, I have this field called A, which just gives it a name, versus here I call it an address because what I do is I put this address as this whole thing becomes an address field. So with the JSON query, the whole thing, like starting from JSON query, with JSON query, I can give the field name, which for example, right, in this example. So if you need even more control on JSON is generated, you can use a thing called JSON path. So here, this example, I'm selecting from this, again, regular table, and we're saying JSON path. And what path will do is the column name, of course, comes up clobbered, but gives you a bit more control about how do you want to represent the data. Examples, if you want to create one document per row, instead of having one big JSON document with everything, you can use a JSON query again. So over here, what we would do is instead of putting these things, well, in this example, I think we picked one. Yeah. If we did not have this, it will actually show up both records in one place, one big row, one big row. And in this following example, what we're doing is I don't have where ID equals 1 or 2, but I run the query and it will represent those two things, those two people information in different rows as in here. Okay. How am I doing on time, Sam? Okay, Sam is on mute, it seems. Can you guys hear me? Can someone say in his chat I'm there alive? Okay.
Oh yeah, you're good. It's
Okay.
7:10 now. We're 40 minutes in.
40 minutes in. Okay. So let's create a new table where we can play with indexes. So this is an index thing that we're dropping table if it exists and selecting ID, blah, 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 author table and adding a constraint on this, right? And we can add some data into the created table using existing DBU users JSON table. So I'm inserting into the table. And this, of course, create a bunch of objects depending on how many stuff I have inside the database. And make sure I do have some stuff, I got 367 rows. So over here, what we're doing is we're adding a column as a different value. So if we do this, so all the columns, we got new columns added. And let's see how this thing looks. So now if I query it, I can actually query it with with part of the document taken and put it as a separate field. So I just see the first name and last name and age like that. If I run a query without index, now this is a small data set, so the value of indexes may not show up that well, but you can still see the difference between logical read and physical read. So we're saying logical reads 41, physical reads 0. Of course, didn't have to go to disk with a small data set like that to get the results like that. Now, if we create a non-clustered index, and then run the query again, you see the difference is logical reads 4. So definitely index is a good idea even for these cases. This is, of course, creating additional indexes. Now here, this is kind of cool in that Azure SQL Engine is smart enough to figure out that the index on last column can be used for the query, even if you access JSON directly. So we're doing DBA users JSON indexed where value last name equals black. And remember, we created an index over here on the last name. Sorry. Here we created an index. So with our query, it's like a function-based query. It's smart enough to know that we have an index on that field, so it's going to query on that. And let's see. Is the last one? Yeah. We actually got 4 logical reads. So I guess in this case, the logical read is same again, probably because data was in memory or something. But you get the idea. If you had more data, then it is supposed to help. Okay, with that is the end of the JSON stuff we have. So we're going to switch our window again. Actually, maybe I should change my display, come up to this terminal. So let's do this. Slideshow, go back to the deck. From current slide, how do I choose monitors? So there you go, monitors, not primary monitor. Oh, come on. Darn it. It's too bad. Okay, sorry, I can't change my display to go to any other monitor other than primary monitor, so it has to go back there. Slideshow. Do you guys see something? No, it's not working. This is not going to work. I'm going to switch my monitor. Screen. This one, yes. Here. It's a bit of a pain. Okay, you should see a demo window there. So documentations, obviously there are tons of documentations and all these JSON functions with examples, etc. I'm going to skip to that in the interest of time. Next up is graph. So graph is again, when you talk about graph databases, quite frankly, Microsoft has its own NoSQL database called Cosmos DB that has a graph API support that can be used. People in the market and outside in the community, they use Neo4j is a very popular open source graph database. But what we're saying here is if you already have a SQL and if you have a need to support graph, you could do that with SQL itself. I mean, again, I have to emphasize the fact that SQL is not meant for a native graph database. If you have extremely complicated graph calculations or graph use case of doing analysis or machine learning stuff like that, then I would not use SQL. But it can do SQL, that's the point. So for small use cases. So what is graph? Graph is like a different type of database in that the primary thing to understand is there are two kinds of entities in graph. One is called a node, another is called edge. A node is like, excuse me, a good way to understand node and edge, the way I explain it is like how you navigate in a car, for example, how GPS actually tracks you, takes you from point A to B. So think of all the let's say we have roads are all like either horizontal or perpendicular. So like, every road cuts like this, right? Then from any intersection A to another intersection B, have so many options of going, and consider each intersection as a node and each road as an edge. So the edges are connecting between two nodes, right? In real life, in SQL, what happens is node is a table, edge is also a table, and each one of those tables have certain properties. You can say a node is a human being. So we all on this call, for example, could be node. And then we have some relationship between us, like we all belong to C# meetup group. That's one relationship. We might be co-workers in the same company, living in the same town, or went to the same school or some stuff like that, right? So that is this is what it is saying. The node has properties. So we can say node is a human being, got name, address, age, like similar information. And then the relationship can have properties too. So we can have the relationship, like I said, has property like did we work together? Did we belong to the same family? Do we live in the same town, etc. So a very commonly widely used demo dataset for graph is this thing called million song dataset. It's like 1 million unique song, 1 million unique users, and 50 million likes. So if you try to represent these kinds of dataset in a relational table, doing hierarchical query becomes inefficient very quickly. And it will show you like how it is easy to do that in graph database in SQL. Case study, as customer case study, in the interest of time, not going through that, you can read through like some customer, BKW, they were happy using graph databases. They actually wanted to use NoSQL database like Neo4j or a Gremlin database, for example, or Cosmos DB, and then some in the way of Azure SQL. Okay, with that, we're going to swing to a demo for graph. And let me pull up my demo environment first. And I need to change the window to there. Actually, stop sharing first. Oops. Okay. Yeah, I may not show these. Well, let's see if let me share my screen again. This should be monitor 3, I think. Straight. Oh, come on. You don't need here. You can come here. Okay, so what you're looking at is this is inside of an Azure VM. I have a database called, as you can see, called Million Song Dataset. And inside of that, some of this query, actually one query particularly that takes about 5-10 minutes time. So in the interest of time, I might skip it, but real brief, show you some of the SQLs, what we are doing here. So we're extending, configuring for external scripts enabled so that it can run external scripts from the SQL engine itself. Is the top? Yeah. This will list me like all the R packages I have installed. Now, R is not needed to do graph query, to be honest with you, but here one of the demos actually, if you go to the GitHub repo, is actually kind of displays that takes the data from SQL and visualizes in a very nice way. And in order to visualize it, you want to use like R, which is the machine learning R services that comes with SQL, and certain packages. So that's why you have this script. So basically, this tells you all the packages that you got installed. So let's run it. This will tell me all the R packages that I got installed. Come on. Be nice. Thought I hit run, didn't I? Yeah, started executing. Oh, darn. Okay, if it takes this long. No, it doesn't. What? Am I not connected? Okay. Ah, localhost. Come on. Databases. Don't go away. Don't know if it's my network at home. I don't think so. This should not take this long. Is it the go-to thing? Wow. This is odd. It was running just an hour ago. This is a VM. We should have it. Okay. Let's see if we can connect back again. Sorry about that interruption. Do we have the service running? Service. Why does it install anything? I didn't ask it to install anything. SQL, come on. Okay, that doesn't look nice. Don't know what happened here. Don't need agent, but I'll start it anyway. What are the service I need? Clean. This looks fine. Of course. Then let's do this. localhost, looks good. Oh, somehow it didn't died on me. This is SQL demo 19. That is A. And we're going to do this. Zoom connect. Oh, thank you. Launchpad services. Don't think I need polybase, so that should be good. Let's run it again. Whew, so much for demo God not helping. So anyway, this is our packages that we have. It's a long story, but essentially Microsoft bought a company called Revolution Analytics, and that's the Revolution. So you can still see some of this name over there. This will tell you which directory. This is important if you're playing with R, like which directory has the R library. So any library packages that you install on your own is going to be installed over there. And you can run queries like this to basically figure out like what hard version of you have. And this is also important. I just learned the hard way in that the latest version of R is I think 4.03 or 1.3 or something. But anyway, that's too high for it to work with SQL databases. So we want something like 3.5. Okay. Let's see, this is for memory optimized table. We don't need that. Memory optimized table, we don't need that. So this graph example, the demo that we have, actually, I'm going to share it. You'll get it in the deck. Is basically we have. Let me show you the files and not necessarily load it because it might be too long. We have files like these files. So if we format it, type. So I have 3 data files basically, and as you can see, one is a smaller one, 1 meg, the other is 82 meg, and this is really big, 2 gig. And these 3 are like the format files. So these 3 tells like what are the format of these data files. So we're using it back to the data studio. We're using it to insert into those tables. So what we're doing over here is that inserting into this table, right? I'm going to skip on that. And this is very quickly. So over here, what we're doing is we're creating a graph table. So notice, and this is important from the graph lessons, the only thing that's different in this query is creating table as what we call node table. So that's the only syntax different. That's what tells it as a node, quote unquote, graph table, right? So create table, blah, 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 as node versus create table, whatever you want, as H, as you can see the last one below. So we're creating 2 node tables, 2 node tables. One is unique song, another is unique user, and the H is the relationship between them, between the song and the user is likes. So we keep counting the likes and see which song is more popular. So kind of going to the query, so the query over here is that we're going to do a insert into the unique song and selecting. So this is what we're selecting from the raw tables. We created the raw tables. We're going to insert into this graph tables now. Insert a unique song, unique user, and insert it into lex. Now notice over here that we got in the edge table, we have a property called from ID and to ID. So this is, again, think of the node and edge, right? Streets between point A and point B, from A to B, that's straight. So it's connecting this node to that node, and the listen count is a property of that. So these are property that comes from the node tables itself. And let's do Yeah, I'm not going to insert those because the insert might take time, but let's do a select from these tables. So we do select top 10 from each one of those 3 tables. Okay. Oh, bummer. Of course, I lost all of that. Could have done localhost, I guess. Come on. Don't die on me. What do you mean default? That is not default. Of course, if I can type. Okay, line 61 started existing. So this is giving me a unique user. So unique user table has user ID information, and this is like stating that this is a type node, schema that, table that, etc. So all this information, as you'll see, is kind of repeated for each of the rows. So that's that. Then there's this unique song, is this one. So we got a node ID, song ID, it got some more columns, song title and artist name. And then we got the another one, which is the likes. So likes is an age table, if you remember. Likes is that, so it says which song, so age ID, from ID, to ID, etc. And then how many likes we got. So that's my 3 query, going to go to 4. And this is the power of graph. What we're going to do is find songs which are similar to the song Just Dance by Lady Gaga. Okay, ignore the comment. Someone's ran this in 3 seconds. It actually runs less than that, I think, here. So we're doing to do this and with set statistics on. So I hope I'm connected. Maybe not. We'll see it. But anyway, I'm going to run it. If it tells me to connect, I will say local host. I can type it. Still use that. And the database will be this. Connect. Okay, so this query came back, I don't know, maybe 2-3 seconds, something like that, but pretty quick. So this is the top 10 songs, similar song, compared to that Lady Gaga. And as you can see, we're querying with the select from, and this is kind of like Neo4j graphical language. So graph query has its separate language. There's kind of two different types of graph language queries. One is called Apache Gremlin. So if you have used Cosmos DB graph, that uses Apache Gremlin standard, and this is more like a Cypher / Neo4j, which is frankly has been around older and more established. So anyway, so this things match the similar song, likes other use. So it's telling you what's the relationship, like how to determine like which songs are related. So there's that, and I think that's the end of the graph demo. I don't know why the connection died. Sorry about that. So we should go back to our sharing screen and different screen. Stop sharing. Let's see, where is my sharing? Camera screen, yep. Now I'll go to number 2. Here. There's that. This is there. You can go to my deck. Okay. Any questions so far on graph or JSON? JSON, graph. Okay, silence is no. So we're going to take to the next step, which is key value store. So key value was probably the first NoSQL database that came up in the market. A good example is Amazon's DynamoDB, for example. Also, Azure Cosmos DB has a key value feature that you could use. SQL does not natively support key value, but if you can think of two things. One, something is not in a slide, is that the document itself, the JSON document we showed is actually a much more complicated version of key value, like that, right? So there is that. And two, people use key value database like Redis, for example, mainly for cache for faster performances. And for that, you have this thing called in-memory tables, memory optimized tables in SQL. I'm not going too deep into that, that's SQL stuff, but basically you can have the table created in memory, optionally persist it in a storage so that it's durable, or optionally you can say, no, I don't care. In addition, with the native compilation, Azure SQL can offer extreme performances. So there are benchmarks like TPC-C and TPC-H. I believe that Azure SQL holds a record of performance in both of those. Okay, I don't have a demo for key value, and this is just some numbers, but to say that over here, we're talking the progression of performance between SQL releases, so SQL Server 2012 to 14 to 16, and excuse me, the performance numbers, how it went up from 12,000 batch requests per second to 300,000 to, what was it, 1.2 million? Yeah, 1.2 million per second. And the technology that enabled that, so from TSQL to memory optimized table to memory optimized table with natively compiled stored procedure that can run on the OS, etc. So some of these features are not, like I said, available on all of the database platforms. So you have to really be careful about choosing the right Azure SQL platform that gets you these features. Okay, I think this is kind of the last of the demo series we have for spatial support. So what does spatial support mean? Spatial support means in Azure, actually I should probably go to the next slide first and then come back to here. There is two types of data. So one is the spatial data and another one is the spatial types. Like, so what do we mean by spatial data? Spatial data can be a geometry data or a geography data. Geometry data is like, think of Euclidean geometry, like a flat surface, like a top of this table where I have this laptop, or your floor, versus the other type of data, geography data, is more like Earth surface. So distance from point A to B, it could vary depending on the curvature of the Earth where we're going, right? So what spatial types of data we support? There are different types of spatial data types we have. There's documentations of that. I'm going to show you some examples of running some simple query if I can find my environment. Did we do this? No, we do that. Yeah, okay, so I found the window I would like to share. So change stop sharing again. Gosh, there's no easy way to share, or at least I don't know. Switch window. Okay, screen. This is very, very simple rudimentary example, okay? What we're doing here is that the top of the script, yes, it is. So let's run the whole script. Actually, let's run it one time. So run that. And then we're going to create this table. So notice that when I create this table, I'm creating a different column type called geography. Now over here, this is implemented using .NET CLR. So this is where you have to be careful. CLR is not supported in, for example, Azure SQL DB, because essentially we don't offer access to the operating system stuff for those past services. But if you go to SQL managed instance in Azure, it will, you do have CLR features. I'm pretty sure, yeah, you do have CLR features, so you have access to these features. So, okay, so we're going to create this table. And all I'm trying to do is inserting the table, a thing called geometry type. So this is a data geometry type, and this is a line string. So what this is from one point to another point, this is just a line, right? And in this following example, we're using this function to return the points where the two previously inserted geometry intersect. Okay, so what is this 2, 1, 2? So what we're trying to do is think of it like a geographical polygon area. So like a state, for example, state of Ohio or any state, any kind of polygon. And a line, think of it like a straight, like maybe Ohio Turnpike that cuts through the state. So what we're trying to do is find out the intersection, like basically where does Turnpike enters on the east side and where does it leave on the west side and what's the distance between them, right? So I think this should have been inserted as well. Okay, this should be 1 and 2. And then we run this. So that's the distance. And over this example, what we're doing is we're creating a table with a persisted computed column using a geography type. So dropping the table, and over here it is persisted in this table. So let's do that. Right. So that's about the thing I have on graph and geospatial. I need to switch window again, unfortunately. Stop sharing the screen. This monitor. Share. Okay, add one. Yep. So on the right-hand side, what you're seeing here is that there are different types of geographical data information that you can support in Graph. XML support, and I'm not doing a demo on this, that SQL also offers extensive support to XML, like read, create, manipulate, kind of like what you saw in the JSON in the beginning of this talk, which is very similar. So a quick recap, what we covered today is like a general purpose, battery included, sorry, that's a marketing term, but database, which has, of course, the security, scale out features, all of that stuff is built in. But the fact is that we can actually use it to store JSONs, to store geographical data, to store graph data, and key value. Yes, we don't have a key value support, but we do have this, like I said, the memory optimized table, and you can actually take the JSON simplest format, that's key value as well. Plus, you can always put some kind of Redis cache on top of the database services, etc. All right, so with that, that's the end of the talk and the demo I had planned. I'm more than happy to answer any questions I have. Also, any feedback, good or bad, of course, give the feedback to Sam if you would like. Anything, anyone?
All right, it doesn't look like we have any questions in the chat either. So Sumit, thank you very much for taking the time and presenting. Highly appreciated.